This wafer is the starting point for almost every piece of modern technology. Same starting point, different designs. From RAM and other memory chips, over to GPUs, processors, and so much more. Semiconductors are some of the most complex objects humans have ever manufactured. They're made inside facilities larger than football stadiums, costing billions of dollars, filled with machines worth more than most houses. All inside clean rooms, thousands of times cleaner than a hospital operating room, because one tiny dust particle can destroy an entire chip. But I have none of that. No billions of dollars, no stadium sized buildings. But what I do have is I have a shed. This started as an empty shed. No clean air, no airflow control, no temperature control, just wood and space. First, I had to turn it into a controlled environment. Insulation, framing to support real cleanroom grade HEPA filters, dedicated electrical, heating and cooling with a mini split. It had to function like a lab, not just some backyard building. I divided the space into two zones, a gowning area and the cleanroom itself. You don't just walk into the cleanroom, you transition into it. Every space also had to be sealed, where instead of expensive plastic paneling, I used flame-resistant drywall, then locked everything in with a water-based epoxy coating to create a smooth, cleanable, particle-free surface. Even the attic space above is sealed and controlled for airflow return. But the real trick isn't the walls, it's airflow. Cleanrooms work by forcing filtered air downwards in smooth, laminar sheets and keeping the space at a positive pressure so contamination can't drift in. Massive HEPA filters scrub the air, and in this small volume, the entire room's air is recycled hundreds of times per hour. But after going through and putting the lab together, the key thing is, did it work? I was able to borrow a particle counter, and I measured 40 particles per cubic foot, and around the edges of the cleanroom, under 100. This puts the lab in a Class 100 cleanroom category, alongside Samsung, Intel, TSMC, at least in terms of particle counts. But outside the shed, that's a different story. Well over 20,000 particles per cubic foot. Same backyard, but completely different environment. This isn't a billion-dollar fab, but the physics are the same. And from the outside, you'd never guess. It's just a shed in a backyard. Yet inside, it's a controlled environment built for semiconductor fabrication. Let me show you. The first space is gowning. On the side, I have power management. Grid power, solar power, local breakers, all isolated and controlled before anything reaches the lab. I have cleanroom suits and supplies, battery backup, and chemical storage. Gloves are on the wall here, always ready because once you step inside, you don't touch anything with your bare hands. Let's suit up. Cleanroom suits are about keeping skin flakes, fibers, and the dust we generate out of the airflow. Once we're suited up, we're ready to go into the lab. It's compact, but every inch is intentional. It has everything needed in order to make this a fully functioning semiconductor R&D space. Plasma etching, removing nanoscale films. High temperature processing through this vacuum furnace for sample annealing. Eye-line lithography for submicron patterning, which I built from a microscope. It operates autonomously through custom software. On the other side, we have a fume hood for chemical processing and spin coating with a 3D printed spin coater. Automated sample cleaning with a robot arm, then building atomic layers with a thin film deposition system. Now that the lab is finally coming together, I can't wait to show you everything. From the engineered tool sets, to how it all works, and all the crazy things that can be built. From circuits, to sensors, to LEDs, and just so much more. Every device starts the same way, with the same core equipment. But for that, I'll need you to subscribe.